Everyone. So now we in our previous class we started learning about enforcing coding styles in our project. So we learned how to set up ESLint, Prettier, and Husky. So in today's class, we'll be continuing with learning how to enforce coding styles in our project. So today, we'll proceed to CI/CD with GitHub Actions. Okay, so under CI/CD with GitHub Actions, we learn what GitHub Actions are. We learn the key components of GitHub Actions. Then we learn about continuous integration and continuous deployment fundamentals. Okay, so first of all, what are GitHub Actions? So GitHub Actions is a CI/CD platform integrated directly into GitHub repositories that allows you to automate workflows. So think of it as a powerful automation engine that can trigger on events, can run jobs, can use actions, and can manage secrets. So GitHub Actions can trigger events, run jobs, use actions, and manage secrets. So I mentioned about four things in which GitHub Actions can do: trigger events, run jobs, use actions, and manage secrets. So the number one, which is trigger on events. So events like push, pull requests, issues, releases, schedule times, and all of that. So let's say, for instance, you built your code and pushed to a specific branch. So in your actions, you specify that if there's a push to this branch, this action should, or this workflow should run. So once you push to that branch, since you include a push event, the workflow will run. You can run on jobs here. The second one, it executes code, test, and deployment in isolated environment. So maybe you want to run jobs maybe every midnight or every Sunday midnight or something like that. So you set up an action that does that for you, also known as a cron job. So once is the time, the job will run and prepare your required results and all of that. So it also uses actions. So actions are pre-built or custom automation components. So we're going to dive deeper into that soon. So it also manages secrets. So securely stored API keys, tokens, and credentials that you want to use to run your workflows and all of that. So when it comes to key components of GitHub Actions, we have the first key component here are workflows. The second one, events. The third one is jobs and steps. And the fourth one are runners. So what actually are workflows? So workflows are just YAML files, that is YAML files, defining automation sequences. So they are actually located in .github/workflows folder in the root of your project. So each workflow runs independently and can contain multiple jobs that run in parallel or sequence. It depends on how you specify it. Each workflow runs separately or independently, but can contain multiple jobs that run in parallel or sequence. So the second key component here are events, which are also triggers. So events can be things like push, pull requests, issues, and all of that. So if a user pushes a code to a specific repository, this should run. Or if a user opens a pull request, this workflow should run, something like that. So we also have jobs and steps. So here we have two things, jobs and steps. So jobs, these are high-level execution units. They run on separate virtual machines. Steps are individual commands or actions within a job. So we also have metrics strategy. So this metric strategy run jobs across multiple environments. So let's say in your metric strategy, you specify your node environment to be node version 18, version 20, and version 2022. So this workflow will run on version 18, 20, and 22 to ensure it's working properly. Last but not the least, the runners. So runners are virtual machines executing workflows. So GitHub hosts some virtual machines for us like Ubuntu, Windows, and Mac OS. But people mostly use Ubuntu, which is Linux based. And you can also host your own runner. That is, those are self-hosted runners. You can host your own runner and run your workflows. Okay, so all of this will not make sense if we don't even understand what CI/CD is. So we'll start with CI, which is continuous integration. So continuous integration is a practice of automatically integrating code changes from multiple contributors into a shared repository frequently. Or let's say we are about 100 people from different countries, different regions contributing to a code base. So you want to ensure that there's uniformity, like everybody's doing what they're supposed to do, and the coding styles, linting, and everything is uniform. So that's where CI/CD comes in. Whenever they merge their code or whenever they push to the dev branch, you want to run a workflow that checks if the code is correctly formatted or all the tests, the unit tests, integration tests, end-to-end tests are passing and there are no mistakes. So you all can both review the code and push it to the main branch so it can be merged in action. So continuous integration is just a practice of automatically integrating code changes from multiple contributors into a shared repository. So you automate this process. You don't want to, okay, anytime I want to push code to a specific branch, I will let you know, oh, I want to push code, so you should be there to see what I'm pushing. No, just push your code. And if the workflow fails, then you have to check why is it failing. Then you make the changes and push again. So if it passes, that's when you open a pull request. And when you open a pull request, that is the first one will run on push. Let's say, for instance, it will run on, and if it fails, then you have to check making it fail. So after fixing it, you will open a pull request so that it will be reviewed by maybe senior software developers, including you. So they will ask you questions as well, something like that. So while you open the pull request, this will still run. So if it fails, you have to fix it and push again and reopen the pull request, something like that. So it ensures that all your code is in accordance with the requirements and the test and every other thing is passing before you can even open a pull request. So they don't have to waste their time fixing some little bugs. So we have CI pipeline component as well. So we have about 6 or more components, but let's say, let me just try to mention 5. We have 1, code commit; 2, automated build; 3, automated testing; 4, code quality checks; and 5, feedback loop. So let me just try to explain what all this means. So for code commit, which is the first CI pipeline component, so the developer pushes code, that is code commit. The second one is automated build. So it will compile/transpile code. The third component is automated testing. So this is unit testing, integration testing, and end-to-end testing. Which the fourth component is code quality checks. That's linting, formatting, and security scans, as I earlier mentioned. And going on, we have the fifth, which is feedback loop, immediate results to developers. So once you push your code, that is code commit, then it will build your code. If the build is successful, to run unit test, integration test, end-to-end test. Or let's say the code quality checks come before the automated testing, because it will have to check, it will have to format your code, lint and scan for security vulnerabilities. And then testing comes in, which it will run the unit test, integration test, and end-to-end test. Then immediately you'll be seeing your feedback. Sometimes if you are, all those things are integrated into Slack channels or Discord servers, Slack servers or Discord servers, where the results are being posted to the servers immediately. Those workflows run, something like that, depend on how your organization wants it. But these are very standard things. So we also have there is just continuous integration, and we have continuous deployment. So they work hand in hand. So continuous deployment automatically deploy all code changes to that passes CI to production environment. So after your continuous integration workflow runs and there are no errors, all formatting passes, linting and tests, everything passes. That is the CI. And then there will be another job in the main branch, because this one you've pushed to the dev branch and everything passes. But then it's not yet time to deploy, because there will definitely be a code review. Because in proper settings, you can't just merge your code to main. There will have to be a code review. So after reviewing the code, your pull request, the pull request will be reviewed. That is a code review, and will be merged to the main branch. So once it is merged to the main branch, that will trigger a push, because we are pushing to the main branch. That will trigger a push that will run another workflow that the organization has put in place. So once the workflow runs, that is where continuous deployments takes in. So the first thing is staging deployment. So it will deploy to the test environment. So once, okay, let's say we have 3 branches. This is the practice they normally follow. 3 branches. We have the dev branch, the staging branch, and the 3 environments actually. We have the dev environment, staging environment, and production environment. So the dev, maybe we may not have a live app for that dev, but everything happens in GitHub where you push your code, they review. And then when it's being pushed to the staging environment, that's where deploy to, that's where it will deploy to the staging or the test environment. And now there will be, after all the automated testing and everything, there will be manual testing. where users will have to click around, see if there are any bugs to thoroughly test the app. And if there are no apps, then there will be integration testing. So this one will be test in production-like environment. So it will be tested in a production environment to see if actually there are no bugs. And if there are no bugs, then the next thing will be production deployment. So this will be deployed to a live environment where consumers will now see the update and will consume the application. So after deploying to the live environment, already there is monitoring set up already. So you track application hit and health and performance. So it depends on how your organization or your company decides to set that up. But there are automated processes for this, where if there is any issue, you receive an email or Sentry will send you, oh, someone tried accessing this page and we got an error, this happened, that happened, and so on. So that is basically CI, CD. Everything is automated. Push your code to the dev branch, open a pull request. So after this continuous integration workflow in the dev passes, you open a pull request. It is being reviewed and everything is okay. The deploy this, it is being merged to the staging environment. It goes live in the staging branch, then it goes live to the staging environment. From there, if everything is okay, it is being merged to the main branch, which is the production environment. Then the continuous deployment pipeline will run and then automatically deploy your code to whichever hosting service you're using. Some people use Render, some use Vercel. I prefer fly.io. If you don't know about fly.io, you can check it out. Fly, like fly, FLY .io, fly.io, because it gives me so much freedom to actually deploy my apps in different regions of the world, anyhow, any second, with just a single command. It's very, very powerful. Sometimes while it also has this Wireshark operating, this private networking and all of that. It's very, very good. So you can check it out. But for beginners, that would be a kind of stressful. So you can also use Render. Render is also good. And so what are the benefits of CI/CD? We already know that CI/CD means continuous integration / continuous deployment. So we have a whole lot of benefits of can you all hear me?
Yes, you can.
Since when did my screen stop sharing?
You are still sharing your screen.
Oh. I don't know. This thing is showing me. Okay. Wait, maybe it's network. Okay. So the benefit of CI/CD, I'll mention about 4. So early bug detection. So that is for issues caught before production. So if you pass through all these processes, there's no way you will not capture a bug or an issue before deploying to production. So let's say there's a linting error or formatting error, something like that. So once the first CI workflow in your dev branch runs, you capture the formatting error or something like that, and you fix it. So if it's something a user will have to test manually before discovering, once you push to the staging branch, there are testers for that. They will go ahead rigorously test it in the staging environment and make sure everything is working as expected. All the features are met and all of that before merging to production, and everything is really cool. So the second benefit is consistent quality. That is automated standards enforcement. So the linting, testing, and everything we discussed earlier, all those things we have to work because Husky will take care of that, even pre-commit, before you even commit your code. It will lint and format. And then in your CI workflow, that will still take place. So we check that out in just a minute. then faster delivery. So it's also reduced manual intervention. So once you just automate the process once everything is pushed to the staging node, the production, the main branch, it will be deployed to production environment easily without any human intervention because it's already automated. Then we have rollback capability. So quick reversion of problematic changes. You can revert or reset a commit in GitHub. So it's deployment. So GitHub also take care of deployment and all of that. So there are some environments that you can actually revert deployments and take care of certain things. So this is great. After all the grammar I've spoken, I believe some of us now understand the use of, most of us understand the use of CI/CD and why it's very important. But I will just quickly demonstrate with a simple GitHub Actions workflow. So when we talked about workflows and the components, the first component, we mentioned that the workflow is located in the root of a project here, say, dot github /workflows, and then we should call the file, let's just call it ci.yarn, like this. Okay, so I created a folder instead of a file. So in the root of your project, you see .github/workflows, and inside of this workflow, you create ci.yarn, or you can just say YML, still the same thing. And in here, the first component of this file is the name of the file. So let's say the name of this file is, should we call it CI, or let's say code quality checks. And the next components are the events. We want to specify some event. So let's go ahead and so thanks to GitHub Copilot. So the first thing we have here on, and the first event is push. On push, we specify the branches we want this to run on. So the branches will do something like, okay, the first branch should be the main branch because we only have the main branch in our project. So the second one should be, let's say we also want to specify pull request. We have the pull request. And if you open a pull request, which branches should you run on? So we only have the main branch. So we'll still specify the main branch. And now let's see what Copilot has got. Check out code, actions, check out V2. Okay, great. Copilot, thank you. And we'll now explain this. Okay, great. So Copilot knows what we want, but install, run. What do we have here in our package EC? We have format. We have links, format check and linked. npm install, so run links, pm run, or let's say format code, npm run format. Then the next one is linked code, npm run links. So I guess we have a build script here. So we can even run a build and make sure that our project is even building. We have a build command here. So in here we can see we don't have any tests. If you have any tests, we'll run the test and then we'll build our project. See build project, npm run build. Okay, so now that we have our file, let's explain what's going on. So this is the name of the file, code quality checks. And the first event, we've specified some events here that will be triggered. So we have the push event and the pull request event. So, but then we'll also have to specify, and if you don't want to do this like this, you can do something like this. Main, add a comma and see, if you have other branches that you want the push to run on, you can say dev, can add a comma, like say staging, all of that. Depend on what you want. But like this is still cool. You remember in YAML file, you can specify an array of items like this. You can see dev, you can see staging, and so on. So that's still correct. This is still correct. So what we are trying to say here, if we push our code to the main branch, this workflow should run. Now, by the time we go ahead and add dev, now we're saying, okay, if we push our code to the main branch or the dev branch, this workflow should run. But by the time we remove this, and this time around, if you have a dev branch and we push our code to the dev branch, this workflow will not run because we're saying it should only run on the main branch when we push to the main branch. So the other one is the pull request. When we open a pull request on the main branch, this workflow should run. So if you have a dev branch and we open a pull request on the dev branch, the workflow will not run because we're only saying it should run on the main branch. So this is basically what this means. Now we have jobs here. So these jobs should be linked formats and build. So we can have multiple jobs. We can have another job like, okay, we can even say this is only linked. And in this linked, we'll only link our project and we'll have another job that actually formats our project. That will be a separate job. After this job runs, the next one will run. And after the next one runs, we have another job that actually build our project. But in this one, we're combining everything in a single job. Linked, format, and build. So this should run on Ubuntu latest. I don't know the latest version of Ubuntu, but it should be 20 something. The last one I enjoyed using was version 20, I guess, something like that. But it should be up to version 25, 26 or so. So you can say, okay, this should run on Ubuntu latest, or it should run on Windows latest, or Windows 2022, right? Something like that. So if you want to run your code on Windows, run this job on Windows, or you say it should run on Mac version 10.15, version 12, Mac OS latest. But in our case, let's run our code on Ubuntu version 22, Ubuntu latest. We want to run this job on the latest version of Ubuntu. So in the next job, if you want to specify another job, you can do something like, okay, this job is test. This is another job. And this job should test like this. This job you can, okay, let me just do this. So this is for example purposes. Now we have multiple jobs. We have lint format build. Then the next job here is test. So runs on Ubuntu latest. So this one you say it should run on a Windows, the latest version of Windows, like this. So check out code. So we're using action. This action will take care of checking out our code. Action slash checkout at V2 of this package. This step here, select an action to run as part of a step in your job. An action is a reusable unit of code you can use to blah, 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 and all of that. So after that, after checking out our code, we have set up Node.js. So we set up Node.js and we specify the node version, which is version 16. And then we want to catch npm so that in our subsequent node setup, these things are cached and we don't need to restart everything. Then we install dependencies, we installed, and then we run test. So the next job step is deploy. So we don't want to deploy if the GitHub ref is not main. So we can only deploy if it's on the main branch. So you want to use this workflow in different branches. You want to use it in the dev branch, the staging branch, and the main branch. But then you want this workflow here, you want this to only be this job actually. You want this job to only run when we are on the main branch. So if you push your code to the dev branch, this workflow will run, but then it will stop here. If you push to the staging branch, it will run, but it will stop here. Then if you push to the main branch, everything will run. This is where we deploy our code. And then we have you have a script that run deployment and all of that, npm run deploy. So, and you can even say this one, I think they say depends. Yeah, depends. Or is it not? It's not depends. Okay, it's already here. It's needs. Needs here means if anything fail, if this job here fail, this one here will not run because this one needs this one to pass. So it will not run till this one passes. So once the lint format build passes, the test job will run because as you can see, needs lint format build. This cannot run without this one being passed. So this one must pass before this one will run. That's why we have needs lint format build. And this one here needs the test. So if the test doesn't pass, if one of your test keys, just a single one fails, you cannot and never deploy your code. All the test cases must pass before the code will be deployed. So if this job step here fails, this deploy step will not and never run. This job here will never run. So this is the use of these needs. So we talked about workflows, event, jobs, and steps and runners. So workflows, events, jobs, and steps. We also have runners. So let's see what's all about, what all this is all about. So we have events. This is a workflow actually. This one here, we have this folder workflows and CIML. This is a workflow entirely. So we have events, which are push, pull requests, and the rest. We have jobs. We have multiple jobs in a single workflow, and we have what's the last one there? The runners. So these are the runners. Runs on Ubuntu latest and all of that. Okay, so now we just need a single job which runs on Ubuntu latest. And let's change this to Node version 22. So now, let me first of all go back to okay, why is it taking time? So we have this. Let's move into the. I guess I've not pushed this. So, okay, not I guess. Okay, so I guess this should even run. So let's refresh this. So I wanted to, so we have tooling here. If you open, okay, so there's something in this tooling that is, let's go to actions. Let me check out why we have that not here. Tooling contributing in the pictures. So okay, this is saying it's because it's a package or something like that. That's the reason why it's not docs. Okay. Okay, so it's saying I've added. Okay. Now I know if you add this schedule. Let's remove, okay, master. Okay, I've removed the Git repository in this. So let's try once more and see. Let's refresh. And we're good now. We're good. Let's check out the actions and see. Okay, so that will not run because okay. It's not in the root. Oh. Okay, so what will we do now is essentially we need this, right? We need this. So let's take on another form. What's happening? We'll need to extract this repo so we can actually, oh, so if that doesn't work, let's come over here, cd. So in the projects, see, sorry. Yes, we should just I want to copy, I want to move. Let's just copy. Okay. So we have TS tooling. Wait. Great. So we now have an independent project. So now we need to create a repository for this so that the action, because this GitHub, this need to be in the root of our project. But that project, the KodeCamp 5, we have done some things there and we really can't put this in the root of our project because of these commands. We don't have prettier and all these things in the root, in the root. We don't even have a package JC in the root of the main repo. So we need to extract this. So there's a reason why I copied it to a different, and then I will use what we call the GitHub CLI to create a new repository for this. So say GH repo create. So I will do it manually so you can also learn something new. Thank God this has brought us to this. And I guess all the commands all the commands I've used to copy this, and I'll be creating a new repo on the command line. If you don't understand anything and you wish to understand, you can just let me know. You can just let me know. So if I hit enter, it will prompt me create a new repository on Git. Okay, so let me just stop this and say Git init. We'll initialize a new repository here. Then we say Git git branch. So let me just clear the terminal so you see what I'm doing, and I will explain. So git branch -m master main. So we want to rename this the master branch to main. So this is how to do it on the command line. So if I just notice what will happen here, this master, if I hit enter, you see that we now have main. We no longer have master. We've renamed our master branch to main. I don't like that master thing. Now I love main. Okay, so now let's create, now that we have an existing repository, let's say git add everything, git commit m, then we say initial commit. Great, so we've added everything. And now it's time to, now if you come over to this repo here, if you come over to here, this place, the repository, we don't have, this is our last repo. We don't have the TS tooling. So we need to create a repository for TS tooling. So we say GitHub repository create. We hit enter. So what would you like to do? Create a new repository on GitHub from scratch, create a new repository on GitHub from a template repository, or push an existing local repository. So we already have a repo locally, so we need to push it. So if I hit enter, path to the local repo. So which repo do you want to push? This is the local one. So if I hit enter, the repository name is TS tooling. If I hit enter, then who do I want to, okay, so this is my default repo, not TechBreed, not Castbyte. So if I hit Christopher, so I hit enter, the description, let me say TypeScript tooling, hit enter. Is it a public or private repo? It's a public repo. So add a remote, yes. What should the new remote be called? Origin, yes, origin. What would you like to push commit from the current branch to origin? Yes. Great. Now, if I clear the terminal, if I come over here and quickly refresh, we see TS tooling. And if I open up TS tooling, here is our project. Boom. And then we have something there. Now, if I open the actions, initial commits, so code quality checks, commit to push to, so it's failing. That's why we see something red. We see a red stuff there. So why is it failing? Let's open up, set up NodeJs. Found in catch at node 20, npm config get catch. Catch service responded with 400. Okay, so let's go back to our GitHub YAML. Catch npm, remove this. See, git add, git commit. You'll see this is core. This is not a new feature. It's not testing or anything. It's something within the core, in a core project, that it doesn't affect any feature or something like that. So say remove npm cache from CI workflow. Hit enter. So git push. Now we can go back, come back here, come back again. And we can see that this workflow is running. As you can see, this is the commit. The core is a remove npm cache from CI workflow. So it's running. And if it passes, you see a green check mark here. So I guess we should just go in. And you can even see, oh, I guess it failed. Great. So it's failing because when it tried to lint our code, it got an error. URL is assigned or never used. Okay. And that is because, let's see. That is because of if you open the source folder for index.ts, this one here. Let's remove this. This is the error. Remove it, and we'll go to okay, git add, git commit message, and this one is a fix. Remove unused. It was a constant, right? Unused constant in index.ts file. Say git push. Clear terminal. Let's check out what we've got now. Come back. Come back. And now, as you can see, you can see how this is playing out. It will not allow you to push your code with some random errors. Now we're linting our code, formatting, and you can see how we're getting all these errors. This is fantastic. As we always say, it is sweet. You know, it makes you, okay, this one failed as well in 10 seconds. So what's the problem? npm run build is failing. And the reason is because cannot find entry point index.js. Okay. So now, if you can check out, you see it checked out our code successfully, set up Node.js for us successfully, installed dependencies. You can see TS tooling, Husky, added 168 packages, found 0 vulnerabilities. And then it formatted our code successfully, all the files we have. It ran linked warning. We only have a console warning in our index.ts. Fine. One problem, 0 errors, 1 warning. So that will not prevent us from moving forward. And then it tried to build our project, but then discovered that in our TS down config TS, instead of the entry point should be index.ts, I guess we're specifying index.js. But let's check that out first. And we have TS config. It should be index.ts. And then we say, okay, git add, git commit, fix, change TS down entry point from index.js to index.ts. You hit enter. So git push. Now let's go back and see what we've got. You can see how this is playing out because we made some errors and it's not allowing us. We must fix everything. If not, we won't be able to push. So there is the use of CI, CD. Now we've had 3 failed commits so far. Now let's open this up. Wow. First time we've had a commit pass. So with this one has passed in just 13 seconds. And everything here is a build project. It's successfully built a project. This and in 26 milliseconds, everything was built and everything went well. So these are not our own steps. So we have post setup Node.js, post checkout code, complete job. So it's doing some cleanup on the machine. So after running your code and doing everything, you know it will have to clean up the machine and make it ready for another step of workflow or something like that. So this one has passed. And if you come back to our code in the TS tooling, you can see that our GitHub, we can see our
Yeah, we can't hear you.
Can anyone hear me now? Hello, can you all hear me?
Yes, we can hear you now.
Okay. So we've seen how we can do this, and that is basically how, this is just the basics. So you can see the last commit, it passed, success, all the commit messages, who committed, what time, and all of those things. So that's just it. You can see the workflow, the file is in here. And if you want to check the actions, you click on the actions tab in the repository and you see all the actions. You see when they ran 3 minutes ago, 5 minutes ago, this one took 9 seconds, this one 18 seconds, 13 seconds, 16 seconds. And so you can see the actor, it's actually Christopher. So I'm the person here. And you can even check the branch, the main branch status, which status is it queued, in progress, waiting, completed, neutral, or something like that, the event. Is it push? We only have one event, which is push. But we can also create for the pull request, if you want to create, well, we don't even need to create a pull request. But if in case we create a pull request, main to main, choose different branches, but we don't have another branch. So let's leave that for, but if in case we succeed creating a pull request, you see that the workflow will still run. Great. So that's it for CI/CD with GitHub Actions, I guess, and I hope we've learned something new today. And do not hesitate to extend your research, because this is just the basic, these are the fundamentals. You need to extend your research and see what you can get out of this, because you are intermediate now and companies won't, as a beginner, it's even difficult for you now to find a job. Not really difficult, but it's a kind of tricky because of this AI stuff, and they don't really believe in beginners because of this vibe coding and all of that. So if you think AI will help you code, and that's not it. While learning how to code, do not use AI. Make sure you understand everything, because the time will come where vibe coding will vanish and everyone who vibe coded will be in chaos or something like that. Great. So moving on. Whoa, we are not done. In our previous class, we were supposed to look at continue with enforcing coding styles, but then because of an unforeseen circumstance, we couldn't make up. So today we've covered that, and we'll also be looking at code refactoring. And most of you will be saying, this is not necessary. I already know how to refactor code. And believe me that I'll be introducing this to you, and this will just be an introduction, not even the full gist. So what is refactoring? This one would be a sharp one. So we just pay attention. Under refactoring, we had, we'll look at what code refactoring is, the key characteristics, the refactoring versus rewriting, the refactoring mantra, technical depth. So for those of you that have been hearing about technical depth and you don't really know what it is, we understand what technical depth is, the types of technical depth, accumulation factors, and all of that. So we learn how to refactor, when not to refactor, and how to refactor. So all this, we just briefly do it. So at least we have a basic knowledge of all these things. They are really, really necessary. if you take note, we've not written any reasonable code for a while now because of all these things we're learning. And there was a time I actually stopped writing code for about a year or so. So I was learning and exploring and learning new things. Then I discovered that being a software engineer is all about problem solving and not writing code, actually. If you want to write perfect code, just master the programming language syntax. Make sure you master the programming language syntax, know what it does. Okay, for JavaScript, know what higher order function do, know what find does, filter does, reduce does. After knowing those things, just relax. And now you have to learn how to solve problems, because problem solving is tricky. And if you're not careful, you'll be messed up. So after learning how to solve problem, all you need to do is, if you encounter a problem, okay, you can even talk to yourself or try to bring about a solution. And I'm actually, sorry to say this, but let me just say it. I'm actually building a platform that simplifies all these things for software engineers. It will be subscription-based and free as well. KodeCamp doesn't allow this. I would have loved to share the Discord server link with you, because it would be really, really useful and helpful to software engineers, both front end, back end, full stack, even those building embedded systems, real software engineers building, aiming to build operating systems and work with all those companies, to be really useful to them. But for now, let's focus on this. So for code refactoring, refactoring is a systematic process of improving code without creating new functionality that can transform a mess into clean code and simple design. So this is basically the practice of improving the internal structure and readability of the code without changing its external behavior or functionality. Okay, so I'm gonna give you a problem to solve. And you will write, you provide your solution. Your solution may work, but if I execute your code, it may run in 800 milliseconds. And I will provide the same solution to that code. And I may execute my own solution. It may run in 1 minute or 900 milliseconds. So there's a difference. There's a performance difference there. Your code is more performance than mine. So there's a chance to restructure my code to be more performant. Even yours, there's a chance to make it execute in 300 or 500 milliseconds. And there's a chance that your code is running in 800 milliseconds. But then if you try to run that code with different inputs, or try to, okay, let's say, try to provide input that will make us determine the execution time or the off and oh, I've forgotten this. Okay, to determine the execution time, you will see that mine that was running slowly earlier will perform better, that yours that was running faster earlier will become worse. Okay, so we'll try to determine the worst scenario. Yeah, the worst scenario for our code and all of that. So refactoring is very, very important. So sometimes you are given a task, you complete your task, and then during code review, they will say, no, what you've done here is wrong. And while building software, we don't just write software. There are rules. And there's a whole lot to this thing, a whole lot, that you don't even have to relax. You are learning per second, per minute, per hour. You are just learning and learning and learning. So there are rules to this, but there are I love about 3, 4, or 5. I always keep in mind while writing code. There's dry. Dry means do not repeat yourself. There's keep it simple, stupid. That's how should I say it's said, or it's said. Keep it simple, stupid. It is called KISS. Keep it simple, stupid. It is called KISS. We have dry, we have KISS, and we have We have other ones. Every line of code is a liability. I love this one so much. So this one here may confuse you. Sorry to say this. Or not to say this. I wanted to show you something, but it's not appropriate. So I will not show you again. But then I will explain something to you and I will show you. Let me create a new folder here and call it refactoring. Let's say index TS. Okay, so in here, let me write a simple code for you. Let me see. Const array is equal to array array 6, right? If you hover over this, it's an array of any. Let's say here we have an array of numbers, array 6. Now let's go ahead and say log array. Now if you go ahead and say, okay, cd KodeCamp, and then we'll say refactoring, so ls clear issue.js. Now we get an error because JavaScript doesn't understand this. Let's do away with this. You see node index.js. Okay, we have 6 empty items. So this is a fixed array of 6 empty items. So we created a fixed array. Then if you do something like this, and you go ahead and log, this one is dynamic. It's not fixed. But this one here is fixed. You cannot add more than 6 elements to this array, 6 empty items. That's what we're seeing here. So we want to actually, we can say, okay, array 6.fill, we can add default items. We can do something like this. Log array. And now we have 1, 2, 3, 4, 5, 6. Now we have a fixed array with 0, initialize with zeros. Okay, so now we can come over here and say, we can see function determine array length. Then we can do something like this. This one is even too much. You can see const length is equal to array.length. Then we can say return length like this. So this one works, right? And let me even remove this one. It's just simple. I want to show you. We have 1, 2, 3. Okay, let's say we have 4 lines of code here. But you know we can reduce this to just 3 lines of code. Because there's a slight difference here. There's a performance issue here. Just it's not noticeable, but just it is, how is it called? Is it negligible or something like that? That's how they normally say it. So we are creating a constant and then assigning the value of array length to it, then returning it. Creating a constant in memory and then assigning this to it is a bit of a work in memory. It is not noticeable, but it's a bit of work. So instead of another line creating a constant and assigning this to it, why not just do something like return array length? Can remove this. Every line of code is a liability. We just have 3 lines of code. So this should give you a sense of what I'm trying to say. So while you are writing code, it depends on how your organization wants it or something like that. Just keep things simple. Every line of code is a liability. And if I remember other ones, I will also list them. I wanted to be mentioning all these things while writing code, but it escaped my mind. But if you check the code I write, I always keep this in mind. Okay, basically, this is it. So we've refactored tiny, just a single line. We've eliminated a single line of code to make our code more performant. So now this function will run, it will be pushed to the stack. And when it's time to return, it will encounter this. And then we just return the length instead of, okay, even if it is at 0.00001 milliseconds, it still affects performance. In creating a constant and assigning the length to it, just return the length directly. Great. Okay, so this is not how we would write this. We first of all check if it's an array and defensive programming and all of that, but this is just an example. So moving on, we have key characteristics of refactoring. So here I'll mention just 4. We have the behavior preservation, internal improvement, systematic approach, and test-driven. So under the key X-sticks, the first one is behavior preservation. So while refactoring code, you make sure that the external functionality remains unchanged. If you are authenticating a user with the password and username, make sure that the external functionality remains the same. So maybe the function you are writing to actually check their email or check their password, there are things you need to change. It's about 20 lines, and while refactoring, you may change it to 20 lines, to 10 lines. But make sure how they used to enter their email, validates, and login, it still remains like that. Nothing changes. Just the code and performance. They may not notice the performance improvement, but you've refactored and there's at least your code is maintainable. It's more performant and others can contribute to it with ease. Okay, second one is internal improvement. So code structure, readability, maintainability, enhanced. So while you refactor your code, the code structure, the readability and maintainability is enhanced. Okay, so I never wanted to show you this, but I'm sorry. I will just have to show you. So we can go ahead and write all of this. Let me just quickly show you. Oh. So I don't know why this is behaving like this, but then. Okay, let me just. Sorry, everyone, for the inconvenience. Something just happened. My system just went off, just like that. So I said, so we're talking about information. The third one, topics. So about topics.
Please, your line is breaking. We can't hear you clearly.
What about now? Can you hear me?
Yes, much better now. Thank you.
Yeah. Okay, that's great. Okay, so like talking about internal improvement, readability, and maintainability. Now, in 20 years' time, if I come back and look at this code, I will see that, okay, this is what this function does, this does. The data it takes in, the return, it throws this error, this and that. So if I come to, maybe I want to modify my schemas. If I come to Prisma and I open, let's say I open schema Prisma file, and then, or let's say I open, yes, I open this. So once I look at this, I'll look at the Prisma, I'll look at the comment here, the central motor representing the user of the application, and then some other comments. Every other thing is here. So okay, this is verification, this is session. This one here is verification. So I will go ahead and read okay. So I'll go ahead and read, okay, used for handling one-time password, OTP verification, such as email confirmation or password reset. So if I come, okay, what is the type? Okay, the type of verification being performed, the target of the verification, the email address or the phone number whatsoever, the secret key. So once you come to this file, it is you don't even need to go anywhere and read documentation. You just come over here and read it. The type of action required, requiring OTP verification, onboarding, reset password, change email to FA, and all of that. So that is that. And you have everything. The project is organized, the README, everything is organized, every file, even on the client side, we have components well documented. If you open this bookmark here, you will see that, okay, this is React, but then it is documented and everything is organized and well written. So everything is documented. So all your functions, in your project would be documented that so that when a user later comes in, they will see that, okay, this is documented. Let me just look at the code. Let me just look at the function. This is what it's doing. Where is the function coming from? Where is it heading to? And all of that. That's basically maintainability. So in the next 20 years, even if you forgot how you wrote a function, what it was doing, by just looking at the function and its documentation, you say, oh, this is what this function is doing. Okay, I can remember how I did this, and this is what I wrote, and this. Even if you can't remember, with the documentation, you follow it, and you'll be able to, record and maintain your code without any problems. So test-driven. So refactoring is backed with test-driven. So you first of all write a test based on how you want it to work, and then you refactor it. And if the test passes, you move to the next one. So refactoring versus rewriting. Refactoring versus rewriting. So refactoring, this is incremental improvement and behavior is preserved. Why rewriting is complete reconstruction, potentially new features. So if you have a function that does something and you want to rewrite it, some features may break and new features may also be added. So that's the difference between refactoring and rewriting. So the mantra I want to talk about, the refactoring mantra here. The mantra of refactoring is clean code and simple design, with the ultimate goal being to pay off technical debt. So you may be asking, what is technical debt? Is it debt collected when in tech? Is it debt or you owe your company, the company you're working for, or something? We don't really know what technical debt is, but here we will learn what technical debt is. So let's understand technical debt. So understanding technical debt, the metaphor or technical debt in regards to unclean code was originally suggested by Ward Cunningham? Like financial debt, technical debt allows for faster short-term development, but accumulates interest over time. So we have types of technical debt. So it may still be unclear to you, but I will show you an example real quick. So types of technical debt, we have the deliberate technical debt, we have accidental technical debt, we have I guess just two: deliberate technical debt and accidental technical debt. So for the accumulation factors, we have time pressure, lack of knowledge, changing requirements, poor communication, and insufficient testing. Insufficient testing is last on the list, but it is not the list at all, because fear of breaking changes prevents improvement. You must test to break changes so you can fix anyway there are issues. Poor communication here comes in where there's misunderstanding of requirements, and then you just implement the feature you so wish to implement. Changing requirements, code adapted without proper restructuring and all of that. Time pressure, we have shortcuts taken to meet deadlines, lack of knowledge, inexperience with better patterns. Maybe you don't really know better patterns to write, you don't have much experience. It will lead you to technical debt. So let's say we mentioned about deliberate technical debt. Okay, so let me just give you a quick example. So a quick example of deliberate technical debt here is quick example. Let's go ahead and say, okay. For instance, we have function process payment, right? And in here, we have about to do, add proper validation. Another to do, implement proper logging. Let's say we have another to do, and this one is add transaction rollback. Let's say we want to add a transaction rollback compatibility or capability, not, let's say capability. And then we'll say return payment dot charge amount, like this. Now you've written all this to do, but you never had the chance to come back and implement all these three features in this function. Now, by mistake, your code gets to production without proper testing, because if you have tested this function, you know that there are features you have not implemented and your test will fail because you to account for all these things. And then you accidentally push this to production. This is technical debt. Now, let's imagine you've done this for like hundreds of this is split payment address payment. You've done this for payments. Thank you, Copilot. You've done this for like 100 functions. Do you know how much debt you are owing? Let's say, let's equate this to let's say this cost 1,000 naira. Now you've done this to 100 functions. That is 100,000 naira you're owing. That's in currency. But in tech, that is a huge technical debt. And if by mistake it is unnoticed and you leave that company, users of that application will face so much pain and the company will lose customers. And let's assume that one day you want to become a boss of your own and you are doing this to company knowingly. That is you're committing deliberate technical debt. You are doing it knowingly. And then let's say one day you become your own CEO and then you hire developers. Don't you think they will do this to you? They will still do it to you. And your users will face pain and they will leave. They will leave for other options. Now just imagine the third to do, add transaction rollback capability. And now you want to pay for something and something just happened in your application. And instead of rolling back this transaction, it was successful. But then the actual subscription was unsuccessful. What do you think will happen? You've taken their money without giving them value for it. Problem go there, everywhere go bust. Then later on, they will complain. You say, oh, it's a mistake, our system, blah, blah, blah. You resolve, but they're not happy. And if it happens for the second time with different users, imagine this happening every month. Maybe it's a monthly based subscription. And this is happening every month to users. Imagine how many users you'll be losing every month. And not just this function, other functions as well, like 50, 100 other functions, causing this to different users. Oh my God, you are done. You are I guess network is having, I don't know. So other developers we have to pay for the damages you've caused. Okay, so we also have accidental technical debts. So let's say, for instance, without proper linting, some organizations are strict. Your function must take in at most 5 parameters. Say refund payment. Let's say refund payment. We have amount, or have param 1, param 2, param 3, param 4. Now, guess what will happen? They've written a rule that by the time we have 1, 2, 3, 4, 5, by the time you add another parameter, let's say payment, you get an error. You cannot have more than 5 parameters, 5 function parameters. So you have to remove this. So they are forcing you to do the right thing. A function should just do one thing. One of the rules of programming. A function should do just one thing. It's very, very important. So by the time you cannot pass the payment, then you'll be forced to say, okay, so why am I using this payment? Can't I just come back and say, okay, function cancel? Can't I just come up and say, okay, since I was passing this payment there, let me just write this function, cancel payment. And then let me just bring the payment here. And then bring in the payment ID. So after doing this, there will be no need to pass in payment ID here. And even I have the user here, but the user is needed here. Okay, there'll be payment ID. Payment ID. But I don't think there should be reason, because the reason will be passed directly there. Should there be metadata? Okay, remove this. And now we have how many parameters left? We have just 4 parameters, and then we call this function. Response is equal to cancel payment. And then we pass all the, we pass the reason refund. And then we're good. 4 parameters. This one has 4 parameters. And we can even make another function that handles other things, the refund and everything. Then this will be reduced to 2 parameters. And then we're keeping our functions simple. By the time we want to test these functions, it will be easy peasy for us. We don't have to, do some kind of, all I can say is programming is easy. It depends on how you consider it, but it's really easy. That's all I can say. Okay. That's good. So for this one, this is just an example of accidental technical debt. So if it happens that the company did not add a link, you on your own say, Carl, okay, since this is a function, let me just write one function that will do everything. Okay, let me just come here and add payment ID. Let me add username and user email. In fact, let me add everything here. Then you end up having 12 parameters in a single function. What is the function doing? Is it buying a house? You don't know. But you have 12 parameters that is doing, and then the function is complicated, complex. The function becomes, even to understand the function, even you that wrote the function will not understand it. Then everything becomes difficult for you. You say, Kai, like this thing will work. Let me just do it like this. Let me just do it. Okay, it's working now. It's handling. Make I no touch them if he can scatter, because you are not sure where to touch and something will go wrong. So you leave it like that. Basically, it's accidental technical debt because you don't really have an understanding of what you're doing. You don't know that each function should do just a single job. Wow. This is very important. Thank God for KodeCamp. Now, we mentioned time pressure, lack of knowledge, changing requirements, poor communication. So all these occur. So I think the two that mostly occur, we have poor communication, the 3, insufficient testing and time pressure. So some companies will say, oh, I need that delivered in 2 days, 2 days. And then you have a lot of work to do. then you cannot test because of time pressure. You just go ahead, blah, 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 the function is working. It's fine, it's fine. Let me move on to the next one. Blah, blah, the function is working. It's fine, it's fine. By the time you start testing these functions, and then you start testing for edge cases, you would see that the blah, blah that you've been seeing is really box, blah, everywhere. So that's where the problem will come from. So all those things. So it's better for you to take your time, sometimes miss deadlines. If it's a new feature, that meet up deadline with technical debt. Miss deadlines and make your project manager understand. Yo, bro, this is what I'm doing. You don't have to pressure me, please. Don't pressure me. And if you try to do that, I will just put your company in debt, technical debt, and run away. Something like that. But don't do that, please. So we also have measuring technical debt, how we can measure technical debt. But that's by the way, measuring technical, that's not really important. So we learn how to, when to refactor. So the rule of three, we have rule of three. That's what I'm trying to say is we have basically 3 rules. So the rule of 3, that is when to refactor. The first time, so write the code to solve the problem. The second time, duplicate with slight modifications, acceptable. That is the second time. The third time, refactor to eliminate duplication. I always do this. And back to this project, I just want to show you something. If you come to UTUs, here and you come to miscellaneous.ts, you see a whole lot of functions here, well documented. And then you see a function, get error message. So this is also documented. And if you hover over this function, this is because of the documentation. Anywhere using it, if you hover over it, you see this, and you don't have to look at the implementation details. So this gets error message function. So there's also a test for it. And the test here is a miscellaneous gets error message function. So if I run npm run test, this function will run and it will pass successfully because we're handling not everything, but at least there's one more case left to handle, and that will be handled as well. So this function is used in the whole of this application. And do not be surprised that this application have about a whole lot of modules. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, about 20 modules. So this gets error message function is used in the whole of this application. And not only that, this one is for the front end, the CN. This is for shared CN. And this invariant response. And we have another one, invariant. We'll use all of this when we start building with Next.js. So we don't want to install this package. We just have to write our own and document it properly. So this is used in the whole of our application. So at first, you may think you don't need this, but by the time you use it, they're trying to make us understand about rule of 3 is, first time, you want to write this invariant here, and then try to use it in your application. So the second time, you will bring out the invariant, duplicate it and use it in another module. And then you discover that, oh, I've used this in 2 places with slight modifications. Then the third time you say, oh, why am I duplicating this function around? What if I need to make changes to one of these functions? That is where this is where we have this utils, and it's utils for that. If you're wondering, this is a full stack framework known as Remix. Now it's known as React Router version 7, just like Next.js. So you can use it to build a full stack application, both your server and clients in just single code base. Okay, so now this is a single function use it everywhere. So we'll test it and we'll make sure it's working, and we can reuse this function anywhere without rewriting it. So sometimes we don't even need microservices. All we need is a proper architecture. That's sweet. So moving on, you can see how the rule applies. First time, write the code to solve the problem. The second time, duplicate with slight modifications. That is acceptable. Then the third time, refactor to eliminate duplication. So refactor to eliminate duplication, that simply means you should refactor and then make it reusable so that you can reuse it everywhere else. Sweet. Wow. So we've mentioned the three rules, the rules of three, the rule of three. First time, second time, third time. First time, write the code to solve the problem. Second time, duplicate with slight modifications. Third time, refactor to eliminate duplication. The rule of three. Okay, so when to refactor, we've seen when to refactor. Um, the reasons, maybe when you want to refactor, that's when you want to add new features. You should refactor. One, when you want to add new features, you should refactor. Bug fixing, when you want to fix a bug, refactor to make the code clearer before fixing bugs to prevent introducing new issues. Then the third one is code review feedback. When patterns emerge that violate team standards or best practices, you should refactor. Then for performance issues, as I earlier mentioned, refactor to improve performance while maintaining readability. Keep it simple, but make sure it is performant. Why not to refactor? So when you're approaching deadlines, unless refactoring directly solves the blocking issue, do not refactor. Why approaching deadlines? If the refactoring directly solves the issues, the blocking issue you're having, do not refactor. Unstable code, code that's changing rapidly due to uncertain requirements, do not refactor. Legacy systems without comprehensive test coverage. So you get one code they don't write 10 years back. You just come in and there are not enough test coverages and you want to refactor, you're going to put yourself in a mess. Do not. Complete rewrite needed. When refactoring costs exceed rewrite cost. If you think why a refactoring exceeds rewrite cost, that it will take you more time, more energy, or more expenses than rewriting the code, you should just rewrite it than refactoring. So now we've seen when to refactor and when not to refactor. Again, how to refactor. So the refactoring process. So do you know that code smells? Code actually smells. So I don't know where I can show you. I've refactored a piece. I would have loved to show you. Code actually smells. So identify code smells. Number one, recognize problematic patterns. Those problematic patterns are the smelling code. Then write test. Ensure behavior is captured. When you capture the behavior and it becomes clarified, apply techniques, small incremental changes. Make sure you make those changes incrementally, small, little by little, to refactor that code. Then run tests, verify behavior preservation. Make sure you're preserving the initial behaviors. Okay, so I was muted all along. I said I would love us to refactor a piece of code base, but then we're out of time. So I'll just call it a day. Guess you raised your hand, you can go ahead and ask your questions.
Hello, good afternoon.
Yeah, good afternoon.
It's not a question, it's more of a plea. Please, I'm trying to follow up, as I said, and I've been following up since. I have a task that has not been graded. Please, can you help me grade? I dropped a message earlier last week, but it looks like you didn't see it.
Are you sure I've not graded all the tasks?
I don't think so.
Have you checked of recently?
I keep
Because
refreshing all the time. I really wanted to reach out one time. I was like, it's like I'm disturbing a lot about something like
not
that.
really. You ain't disturbing because I guess, is it a stage 4 task?
No, not stage 4. It's like stage 2 task.
Okay, two. Oh. Okay, so I guess this escaped my. Okay, I will check it out and grade you. So
Okay, thank you.
right away, yeah. Sorry about that. Okay, so any other questions so far?
Yeah, hello. Thank you for the session. So I just want to say, if it's possible that you could create a session where you can take us on data structure and algorithm, because you are talking about problem solving techniques. So I just feel like if you know DSA to also help with that, the big O notation that you are talking about. So please, if you could just create a session where you can take us through that. Yeah, thank you.
Okay. I'll get back to you on the server. Right now, I'm quite busy with tight deadlines that schedules to meet, but we'll definitely do that due time. Yeah. Okay, so let's call it today. I think our time is over. Bye, everyone. If you have any questions, you can drop on the channel.